Welcome to TEC Tube. I'm Dave Herman with Tech Support. Today we're going to be going over pressure switches in a furnace. The way we're going to be checking them is with a dual port manometer field piece model that we're going to be using, and also field piece multimeter. We're going to be checking the switches on the electric side and on the pressure side. We'll be able to identify if the switch is working properly, and if the switch is working properly, then we'll be able to know we have to check somewhere else in the furnace to see where our problem might be. Okay, the first way we're going to check the pressure switch is the voltage through the switch. So it's a 24 volt circuit, so we're going to get the check by making sure we have 24 volts through the switch. So the first thing we're going to do is make sure we have a call for heat. And then we're going to get on our switch. So we're going to be on terminal on each side of the pressure switch. We got two terminals. And as you see right now, the meter is showing we have 27 volts on, being on each side of the pressure switch. Now once the inducer starts up, we should lose that 27 volts. Right now we have one live side of that switch where we have the 27 coming in, but there isn't anything on the other side. There is no voltage. So once that switch closes, right now we're at zero. Because now we have our 27 volts on both sides of that switch. And that should continue throughout the cycle as long as everything is clear, our venting, our drains, and there is no problem within the system. So it'll start off with 24 volts, 24 volts plus, depending on the voltage of the unit, coming through on one side. Once the switch closes, we'll have voltage transferring through both sides. So if I take my leads off, and if I just check the ground, so I'm on one side of the switch, check the ground, I have my 26.3 to be exact. If I check the other side of the switch, I have 26.3 on that side. So we know our switch is good. Now if there was a case where I didn't have the voltage on the other side of the switch, I would know there was a problem. Not necessarily with the switch itself, possibly with the switch, but there is a problem in the system somewhere where that switch is not able to close, or there's a problem within the switch itself. Okay, another way to check the pressure switch is for continuity. So what I've already done, I've removed my wires from the pressure switch. I want to make sure they're not going to touch anything or bump anything. I don't want anything to short because we will have power going through wires, once we start up the furnace and get things going. So power onto the furnace. I'm going to turn up my thermostat, and then I'm going to get on my pressure switch with my leads. When I'm on there initially, I don't have continuity. I will wait for the signal once the inducer starts and that pressure switch closes for the signal from the meter to let me know that I do have continuity. And there's the ringer, so I do have continuity on my switch. Okay, now we're going to check the pressure side of the pressure switch. To do that, we're going to use the field piece dual port manometer with a separate pressure switch tester. So that's going to give us the option to actually test the pressure switch itself. There's different ways to test the pressure switch. You can get in line with the extra pressure tubing on the unit between the connections of the pressure switch hoses and the inducer, or possibly the collector box. But the way we're going to do this today is specifically the pressure switch itself with this specific meter, which is going to tell us exactly what that pressure switch is doing and whether it's functional or not functional. So then if we know our pressure switch is okay, we'll be able to look further into the system to find out where our problem is. So the first thing we're going to do is we're going to pull off our terminals and our wires on our pressure switch. We're going to remove those because we don't need those on there. And then the other thing we can remove from the pressure switch is the hose off our negative port and get that out of the way. Off our manometer, we're going to have our 2 lines connected to that. One is going to be on the pump side, which is going to create a negative pressure for the switch, and the other side is going to be the port that is going to read the actual pressure we're getting. And then we're going to have another hose that will connect to the pressure switch. And those will connect together once we purge our manometer. And then on the wiring side of things, we're going to have 2 wires that plug into the top of the manometer, which are going to track what's going on with the switch opening and closing. We're going to take those 2 wires and connect those to each side of the pressure switch. So what we're going to do from there, once again, when we do our test cycle, we're not going to have this connected. We're going to let this run through its test cycle, run down the amount of seconds on the screen, and once it goes to 0, it's run through its test. Then we're going to connect this up and get ready to test our switch. So we're going to turn our manometer on. We're going to hit the test. Right now it's counting down from 13. It's testing the pump. And we are at 0. So we're all set. I'm going to connect the hose from the pressure switch to the Y that we have connecting to our 2 hoses that are going to the manometer. This pressure switch closes at 0.7. So I've already checked that. So what we're going to do, our up and down arrows on here, we're going to increase the pressure from the pump. And we will get a red light indicator when that switch does close. So we will know the exact pressure when that pressure switch does close. So I'm just going to keep working with the up arrow, working to hopefully that 0.7 range where our pressure switch should be closing, and we should get the red indicator light on to show us that our switch is closed. And as you get close on approach, you will want to pay attention, because as the pump is moving, you may pass that 70, you may not catch it exactly, so you do want to pay attention as you approach where your switch should be closing. We're at 0.63, and this is all measured in water column. 0.66, 0.67, 0.68, 0.69, 0.7, 0.71, 0.72. So at 0.77 we did kick on. So just a little bit over 0.7 we did kick on, or I should say close. Our light kicked on and our switch did close. So now we're going to reverse it. Our down arrow, we can reverse that. Now we're going to take away the pressure in the same way. We decrease that pressure, work our way back. And at 0.75 our switch opened. So this pressure switch is opening at 0.75 and closing at 0.77. So we know exactly where this switch is opening and closing at. So that is in a close enough range where that switch is okay. So we know that switch is functioning. So if there's a problem within the furnace, not operating because of a pressure switch fault, we could check our other pressure switches also. But we work our way through the system then. We know our switches are okay once we check them all. Then we go through and we check any other possibilities within the system that could be causing our issue and causing our pressure switch fault. We've gone through checking the pressure switch a few different ways. We checked it electrically to make sure we had continuity and voltage going through the switch. And then we also checked it with our dual port manometer with the pump to make sure the switch was opening and closing at the point where it should be. Once you confirm that your pressure switch is okay, check in one of these ways. You now know if you continue to have a pressure switch fault that the system problem lies somewhere else, not the pressure switch itself. Thanks for watching.